Hey guys, Joe back at it once again with some OCR FSMQ, and today we are doing the June 2018 past paper. I'm actually recording this from my holiday in Florida, where we are getting it done a couple of weeks, or at least a couple of days before results day perhaps, so at least that's an improvement on last year. I'm going to try my best with it. These are just my attempts at this year's paper. Some of the working will be a bit scruffy as well, so please do appreciate that when you watch this. But I thought I'd get it out for you guys while I've got a little bit of downtime, and we'll race through the paper. And obviously any of you guys can leave your input down in the description. Also, I want to say that this will be the last maths video on this channel. All future maths content will be on my Captain Goodspeed Maths channel, which you can find on the channel homepage and down below in the description. So let's get into it. June 2018 FSMQ, the last one of the old spec. Solve the inequality 2 minus x is less than 1 plus 3 brackets x minus 2. A nice easy question to start us off with. So we've got 2 minus x is less than 1 plus 3x minus 6. You might hear some background noise, by the way. Obviously, I'm not on my own on this holiday, so we'll just have to go with that. But expand the bracket so you get 3x minus 6, and then we'll move on. It's very difficult. So 3x minus 5. So 7 is less than 4x. Therefore, x is greater than 7 over 4. Nice easy 3 marks there. Question 2, the gradient function of a curve is given by dy by dx is equal to 2 plus 2x minus 3x squared. Find the equation of the curve given that it passes through the point 2, 3. So we're given dy dx, we want y, so we need to integrate both sides with respect to x. So we integrate the function that they gave us with respect to x, so we get 2x plus x squared minus x cubed, plus your constant c, don't forget that. And to get rid of that c, we're going to have to use the point that they have given us, 2, 3. So we set y equal to 3, x equal to 2. We race through it, and we end up with 3 equals 4 plus 4 minus a plus c. So therefore c is a 3. And don't forget to write your final equation, y equals 2x plus x squared minus x cubed plus 3, which was your c. So another fairly easy 4 marks if you know what you're doing there. Question 3 then, the graph of y equals x squared plus 2x minus 3 is given in the printed answer book, which I don't have, unfortunately, so I just worked things out the conventional method, factorization. So x equals minus 3 or 1. You would have been able to get that from the printed answer booklet though. And yeah, the second part of the question, by plotting a straight line, I just solved this equation through conventional methods as well as factorization. So x equals minus 2 or 3. Yeah, I didn't have the printed answer book. They're the answers that you should have got from the printed answer book. Sort of, you would have had a curve and some axes, and you would have said, well, it's here and here. So yeah, you would have been absolutely fine on that question. So 4 marks again, fairly easy. So this one is the first real interesting question on the paper. So you're given that the acute angle theta is such that sine theta is a fifth. Find the exact value of each of the following. So cos theta and tan theta. So if we've got a right angle triangle with theta as the angle, we know that sine of that theta is a fifth. So that must mean the opposite over the hypotenuse is 1 over 5. So the opposite is 1 and the hypotenuse is 5. And through Pythagoras we can then work in reverse to work out that this side is root 24, which is the adjacent, if we think of that as our right angle. So from there, you know that cos is the adjacent over hypotenuse, so that's going to be root 24 over 5. And tan theta is going to be opposite over adjacent, which is 1 over root 24. Next we've got this grid. Unfortunately, I can't see whether that's shaded or not. So again, it's going to be difficult. We know that the equation of the curve is that. Don't know why the line came up on the top, but find the area of the shaded region enclosed by the curve. So what I did on this question is assume that our goalposts are between 0 and 3, so I assumed that it was shaded like this. I've probably drawn this in later on. There you go. I did draw it in. So I assumed that that is what we were integrating between. So we integrate between the limits 3 and 0 of that curve. So we get that, which is 2x cubed minus x to the 4 over 2. And we put the 3 in, put the 0 in, and we end up with 13.5 units squared. So, question 6, simultaneous equations, nice and easy. I always like to match my middles, so we're going to times the top equation by 3 and the bottom equation by 4. So we get that. The middles are now a match. We add them together, and we get 37x equals 74. That's convenient because that means x equals 2. We then put that x into any equation we want, and find out that 4y equals 12, so y must be a 3. Draw a rough sketch, so you can draw a rough sketch of the two lines. It's a bit like linear programming, and you'll get the same solution there for part 2. But 4 marks definitely easy. The other 2, don't worry about them too much. It should have been a piece of cake really in your printed answer book. So there you go. I've just drew a quick sketch of the lines, and that's how you would sort of graphically show the answer. So question 7, find the coordinates of the points where y equals 7x cuts the curve, y equals x squared minus 2x minus 5. So these are two equations. They're telling us what y equals at both these points, where if they cut, that y point must be equal. Therefore we can set 7x minus 9 equal to x squared plus 2x minus 5. We sort of rearrange, if you like, and that is a nice factorizable equation to get x equals 4 or x equals 1. You're not done yet though. We want coordinates. That means we need x and a y, so we need to put those x coordinates back through. Probably this equation is the easiest one to put it in. So we get y equals 19 or y equals minus 2. So they are your two coordinates. Determine whether the line is normal to the curve at either of the points. So what I did for that is I did some differentiation, because we want to know whether it's a normal. So when x equals 1, which is this one here, dy dx equals 4. So it can't be the normal, because we've got a gradient of 7 here, and minus a quarter is not the negative reciprocal of that, and similarly with that one, minus a ninth, or minus a ninth, sorry, isn't the negative reciprocal of 7. So basically, no is the answer to that one. Couldn't really do it any more mathematically myself, but I've been out of the game for 2 years with FSMQ, so yeah, you guys might have a better answer to that, but 4 marks should have definitely been fairly easy. Question 8 then, simplify this equation. It's completing the square really. So what we want to do is times throughout by 4x, so we get rid of that and we get rid of that, so we end up with a 4 there on the top. We end up with an x there, put the brackets round, and you end up with what we've got here. So we just expand that up, and then we want to put it in this form here, which is completing the square. So tidying that up, we get that. Half the coefficient of x, and we get x plus 1 squared minus the unwanted square plus what you already had. Take stuff over the other side, and we get that. And finally, we actually no, that is correct. So q is the sort of constant on the other side, 1 minus 4a. It is in terms of a as well. Second question, hence write down the range of values. Well, we know that the left hand side must square root to be a positive number. So therefore, the right hand side cannot be less than 0. So therefore, a is less than a quarter. If we set this right hand side to 0, if you like. What's the last part? Solve the equation when a equals -1. So we literally just let a equal -1. So we get x plus 1 squared equals 5. Remember that when you square root both sides, when you square root something, you get a plus and a negative answer. Therefore, x is equal to -1 plus or minus root 5. Again, nice and easy. Question 9. Dead easy binomial question this. The proportion of people who are left-handed is 20%. I'm just going to put this one on the screen and you guys can sort of take a moment. There's not really much to say about this. All I will say is that this part here, just take 2 of the bullet points on the screen. If you want to see how to do binomials, I've got lessons on it. It's really as easy as just putting the numbers in and getting your calculator out. That is a really simple question in my opinion. It could have been a lot worse. Question 10. Now this is where it gets messy. It's a very difficult question, I would say. Explaining why P is the centre of the circle. Well, we know that from the question, GP is equal to PX, which is equal to AP. So they're all the same. And if we have a X and G being a diameter, if you like, A is a radius, and P is the centre point of that. So that is always going to be the centre of this circle. AX is always horizontal. I've tried to demonstrate that with this diagram on the right hand side. X is at A and Y is at B when the door is closed, and when it's open, of course, X is going to be over here, Y is going to be over here. So X is always horizontal. I don't know how to explain that mathematically. Now finding the height of Y when AGB is 40 degrees. So this is our 40 degrees here. And we want to find out what Y is. We know that this is 40 degrees because of opposite angles. Therefore, this is 140 because angles on a straight line add up to 180. And through the same argument of opposite angles, that's 140. They all add up to 360. We know from the question that this is 60 centimeters. This is 60 centimeters. It doesn't really matter, though, to be honest with you. We know that this whole thing here, it's very difficult to see this, but that is 120. This is a right angle, AX, up here, up top. So we can work out the side length here, if we call it X, I guess, because we know that this angle here is 40. It's very difficult in this colour. Let's switch to green. So this angle here is 40. We know that this is 120. Therefore, through SOHCAHTOA, we can work out that it's 120 cos 40, which is 91.9. We also can work out this because we know that that is 40. We know that this is 80 because the whole thing from Y to X is 200 centimeters, I think. Yeah, XY is 200 centimeters long. Therefore, 60 add 60 is 120. 200 minus 120 is 80. Through the same argument, SOHCAHTOA, that's going to be 61.3. We know that A to B is also 200 because of when the door is... sorry, A to AB... Where does it say AB? Well, because the door fits in there, if you think about it. When it's here, the door fits in there, so it's 200. So it's 200 minus that, which is 46.8. Next question, a circle has centre 0, 3 and radius 3. Show that the equation of the circle is that. Well, dead easy question. X minus a squared plus y minus b squared equals r squared. So we just put the numbers in for that. Expand and tidy up. and you get x squared plus y squared minus 6y equals 0, which is in exactly the same form as that. The line y equals mx minus 2 passes through the point P, which is 0, minus 2, and is a tangent of the circle. Find the two possible values of m. So this is the diagram I drew. These are the two tangents. They've got to pass through this point P here. So that is that. So yes, so basically it's going to be plus or minus m. So essentially what we're looking for is m to be a repeated root, not a repeated root at some point, but a plus and minus answer. So we're looking for something squared to equal m, or m squared to equal something. So if it passes through the circle, we know that y equals mx minus 2 must sort of pass through this circle. So we can paste in y. We know what y is at this point, mx minus 2. So we paste that in, and sort of expanding and tidying up. You guys can do this in your own time. So expanding and tidying up, I've ended up with this quadratic equation. Now what we want is b squared minus 4ac to equal 0, if you think about it, because we want m squared to be plus or minus. So to get that, well, what have I done here? Let me just think about that for a second. Yeah, all we're doing is using this as b, this as a, and this as c, and put it into b squared minus 4ac equals 0. Expanding it out, you get 36m squared equals 64. So m equals plus or minus 4 over 3. So that is your two values of that. And find the lengths of P, A and PB. Well, PA, so this is A and this is B. So we're basically finding this length here. So we know that a tangent meets the centre of the circle at 90 degrees, like that. We also know the length of this, because it's basically a coordinate 3 to minus 2, so that's going to be 5. We know that that's a 3. A classic Pythagorean triangle, so that's 3, 4, 5. Whoops. And we get that. So therefore, PA is equal to 4. PB, by that argument, is going to be 4 as well. So that should be your answer. A tough question, that one, admittedly. Question 12, again, I'm going to leave this one on the screen. You can sort of think about it yourself, really. Parts A and B are pretty simple, I would say. And then part C, yeah, basically the word you're looking for there is maximum. So we're looking to do some differentiation to solve problems. You know, I will probably go through this in more detail at some point in the future. But that is all the answers you need on the screen there. Question 13 is again one that I'm quite happy to just put on the screen. I know I probably shouldn't do this, but it's a great question. It really is a great question. I love doing this one. So please do take the time to have a look at that. But I know I appreciate a lot of you guys will probably just be here for the answers. It is the last one on the old spec, so there's not much point going through the method. They are the answers that I got. Again, they might not be right. Have a look at it and see what you think. And the final question then, two cars P and Q accelerate from rest at a point 0 at the same time. P accelerates uniformly at 2 meters a second. Write down a formula. So this is just a SUVAT. So we've got an initial speed, we've got an acceleration, and they do it at the same time. So s equals ut plus a half at squared. Then we end up with s equals t squared from that, simply because they start from rest, so that becomes 0, as I said. Using appropriate units, find that. So we're looking for a final speed, so v equals u plus at, u 0, a is 2, so v equals u plus at, t equals 12.5. variable acceleration, very easy, sort of integrating as you go. So a is equal to that, so v is equal to the integral of that, and then s is equal to the integral of that. Working out your constants as you go, and then finishing off, show that at the time when p reaches 90 kilometers, q is travelling at a speed just less than 130. So basically putting everything together, we've worked out a formula. We know what k is, so we put that in, and we end up working out that v is 129.375, which is just less than 130. So that is where I'm going to leave it for this video. Hopefully you found it helpful. I appreciate, I haven't went into massive detail on the last few questions there, but I know a lot of you guys will just be wanting the answers anyway. So let me know what you think down in the comments. Make sure you go over to Captain Goodspeed Maths for future maths content. Thank you very much for watching, and goodbye.